Okay. Hey everyone. Disclaimers. I saw a lot of slick slides and a lot of presentations which really were amazing. I don't have any slick slides. This is not a pre-prepared presentation, and I'm not talking about any specific product, primarily talking about open source technologies, and that's what it is. So purely talking about securing a supply chain. So my name is Pradeep. I'm an applications platform architect with VMware, primarily working with our product and engineering teams and our field teams to ensure that they both align with each other and ensure that customers get what they need from our engineering teams. From a supply chain perspective, how many people here are platform operators or people who run platforms for development teams or create supply chains? Okay. How many people here? Hold it. Can you folks at the back hear me? Sorry about that. Okay. How many folks here use supply chains as developers or engineers? 1, 2. Okay. Okay. So that's cool. How many people here are from a DevSecOps background, wherein your primary role is securing supply chains? Okay, cool. So I can see the sneak guys. Okay, so primarily talking through in terms of securing a supply chain and the current open source technologies that we are working through in terms of ensuring that we can build secure supply chains. When we are talking about supply chains, there are various vectors of attack. While building a supply chain itself is a very hard job to do, securing it is even more harder because it's a real honeypot in a lot of ways. And with a lot of organizations doing a lot of automated supply chains, it's become a larger honeypot for a lot of people in terms of attack vectors. From a attack vulnerability perspective, the various vulnerabilities in the supply chain. From a source integrity perspective, you can have developers submitting bad code, mostly unintentionally, rather inadvertently, but sometimes they do it. In some cases, you have your source control being compromised and your source being impacted. In a lot of cases, source gets modified between your CI/CD pipeline and your source control, which again impacts your source. Within the build integrity, we have seen build platforms themselves being compromised and malicious code being injected into your build platform itself. From a package repository perspective, there are a lot of instances where an organization's package repository has been impacted and the packages or the build artifacts being generated through the build system have been impacted. Another one that we have generally seen is external package repositories being impacted. Microsoft bought NPM, which was huge because there was a lot of vulnerabilities floating through there. So there have been a lot of attack vulnerabilities happening on that front too, wherein packages have been impacted and people have been using malicious packages inadvertently again, resulting in a lot of attacks happening through the supply chain. So primarily looking at all these various factors, and one of the things that we really need to understand is this is what we are all working on. Almost all, and when there was a particular vulnerability which was identified, this was immediately reported, and once this vulnerability was reported, everybody literally jumped onto it. In fact, the number of people jumping onto it, I don't know if you would know this, but sorry, yep. There were 10 million plus attacks happening every hour just because of one single compromised package. And platform operators everywhere were rushing to plug in holes, trying to patch. People weren't sure what package they were using, which version was impacted, which application was using which particular package, how many applications are using these packages, which containers are impacted in production, how many containers. So nobody had any visibility in terms of what was the impact around all of these things, right? Another example, so this was, I'm in New Zealand time zone, so it's time to pick up my son over there in Australia. I'm sorry. So another one that might be well known is a SolarWinds attack, where the Log4j was an open source package. SolarWinds was is a network monitoring software. It's a pretty large corporate supplies network monitoring software and IT infrastructure monitoring software. Again, they were impacted by a malicious piece of code which was injected into their update system, and when this update was rolled out to customers, a lot of customers were impacted, and SolarWinds had, Orion was their update software, and that was impacted, and this resulted again in malicious code being pushed out to a lot of customers across the globe. That's around 18,000 customers were impacted by one malicious piece of code being pushed in and the updates rolling out to all these customers. But what's interesting about this attack was that even before we knew about the attack, it was 14 months. The attackers had 14 months of dwell time to sort of understand what was happening, to be able to build maps of networks around all these organizations and to sort of understand what they're dealing with and exfiltrate data. In fact, they were exfiltrating a lot of data before they could even be identified to say, hey, there's this attack which is happening. And all of these are examples of supply chain attacks. These are not attacks on end customer systems or endpoints that we're talking about. These are attacks wherein malicious pieces of code were injected into specific parts of your supply chain was compromised, or packages being used in supply chain was compromised, and this further spread out like wildfire, because once your supply chain is compromised, you're pushing out software to all your customers out there, and they're impacting them too. So a major part of, while building supply chain society, a major part of it is also about securing it. So what are we doing in the open source community about it? So within the open source community, one of the areas that we're dealing with is called SALSA, or supply chain levels for software artifacts, wherein it's a program that's coming out from a lot of from OpenSSF, and it's being contributed to by a lot of organizations, wherein we are talking through in terms of how do we secure supply chains, what are the artifacts, and what are the various principles of how do we sort of ensure that supply chain artifacts are secure. It's also a capability model. It has various levels. There are primarily 4 levels to support it. It's maintained by OpenSSF, and there are large contributions from a lot of open source community members. SALSA primarily has 4 control categories. Primarily, it's looking at how can a source be impacted. So it's looking at, okay, your source should be version control, it should have verified history, source should be retained indefinitely, and at least reviewed by 2 people. From a build perspective, it's looking at, you should ensure that you have scripted builds. Your build system should be completely scripted. Your build system should be IAC, primarily through infrastructure as code. Your build system should be ephemeral, in the sense your build system should be temporal. You use your build system to build an artifact, and then poof, it disappears. It doesn't exist forever. There is no older artifacts staying back which can corrupt your system. So every time you build any package, it's a brand new build environment that you're creating, and the build environment goes away once you build your package. Your build should be reproducible. It should be highly reproducible, wherein you can go back and recreate the exact build that you were able to achieve at a particular point in time. Another aspect is provenance. We will talk about what exactly is provenance, but you have to ensure that provenance should be available for your software artifacts. Your provenance should be authenticated, it cannot be falsified, and it should ideally be service generated. And the last one deals with common factors such as security, access, and how you provision users within your build system, primarily super user access and a bunch of others. These are the various levels, so rather I'll just run through them. In level 1, SALSA recommends that you have an automated build process, and you generate provenance of all your software artifacts. Basically, provenance is to say, you know what you're building, and you know the antecedents of the software package that you're producing, and you know what it is comprised of, and you know what are its dependencies, and you know its version, on every other factor that you need to know about the software artifact that you're producing. Level 2 talks about version control. It talks about your build being hosted, and it also talks about assigned and authenticated provenance. Now, it's not only just about generating provenance. We've also seen, even though we can generate provenance, your provenance itself can be attacked and it can be modified. So it's not just about generating the fact that you're producing a particular software artifact and all the various pieces of your software artifact. It's also about securing it by signing it and authenticating it. Level 3 is about making sure that your build platform meets necessary standards, and your build can be audited at any point in time. And it's not just your build which is being audited, but also your build environment which can be audited at any point in time. And level 3 also ensures that there is a guaranteed integrity of provenance. I will also run through in creating provenance using frameworks. Level 4 is primarily 2 people reviewing all changes, but more interestingly, it's about hermetic or reproducible builds. And when we talk about hermetic builds, it's air gap build environments, wherein you know exactly what's within your build environment. Nothing from outside gets into your build environment, and your build environment is only one exfiltration path, and nothing else is allowed in, right? So that's level 4. Okay, so we've been talking a lot about provenance. So when we talk about provenance, it's basically about knowing exactly what is your build artifact, what are you producing, what is it composed of, what does it contain, and what does it expand into. So that's provenance, and you have to be in control of the provenance of the software artifacts that you're generating out of your build pipeline. And that's key to ensure that your packages are secure and that you're not further creating infections or issues downstream from yourselves. Any questions so far? There's a lot of terms and theory that's been introduced. Either I didn't make sense. Okay, so in terms of provenance, this is the primary aspect in terms of provenance. So you generate provenance by generating what's called a software bill of materials. It basically says what does your software artifact contain, what are all the various components that it's made up of, what are its versions, what are all the dependencies that it needs, and it not just includes the primary dependencies, it also includes transitive dependencies, the second order and the third order dependencies of your packages. It also lists licensing information. Licensing information is key. A lot of people still are not very aware of the differences between MIT licensing, GPL licensing. They are very critical in how you consume packages and how you distribute packages, and you have to be very aware of how you do it. Then it also lists OS packages. A lot of our containers have base OS. All our containers definitely have base OS packages, and having knowledge of what is in those base OS packages are critical. Hand on heart, how many of us know all the packaged artifacts inside our containers that we deploy into production? So when I sometimes run SBOM generation on some of the containers in production, I see there are 130 to 140 packages, and I can tell you at least 60 to 70% of them are not used by the application running within that container. They're just lying out there, and they're increasing your surface area of attack and doing nothing else. Okay, SBOMs are primarily used for compliance review, security assessment, as I said, license compliance and integrity verification. We'll just jump through some of these. These are known. There are two primary specifications for generating SBOMs. One is SPDX and the other one is CycloneDX. I've also put in SPID. SPID is a much older format. It's not in much use, but the primary specifications that I use to generate SBOMs now are SPDX and CycloneDX. SPDX stands for Cyclone Package Data Exchange. It's from the Linux Foundation, and you can generate SBOMs in the SPDX specification in various formats. You can generate it using as RDX, RDF, SPDX, YAMLs, or JSONs. The primary formats that I'm seeing generally now are JSON formats, but people either use an SPDX specification format or the CycloneDX format. And these formats are further improving as they evolve. Okay, so now and there are various ways to generate, for example, SIFT is an open source tool that can be used to generate these specifications, and there are a bunch of other tools also coming out which allow you to generate. Microsoft has right now come up with a tool to generate SBOMs. Docker Desktop is a tool to generate SBOMs. So a lot of organizations right now are building tools to generate SBOMs. So right now it's not just about generating SBOMs. As I said, we've also figured out that even though you can generate an SBOM, it specifies what's within your artifact. That SBOM itself can be manipulated and mutilated in a lot of ways. So you have to make sure that you can attest your SBOM. So now there is a concept of attestation, wherein you end up attesting your SBOM. So what you're doing as part of the attestation process is you're cryptographically signing the SBOM to say that this particular container or this particular software artifact contains the software packages listed within this SBOM. From a cryptography perspective, it's basically the SBOM is the container image is a subject, the SBOM is a predicate, and the signing key says the subject, which is a container image, contains the software packages listed in the catalog generated by the SBOM, and it sort of ties in the whole thing together, and you sign them both together to say this particular container contains these software packages as cataloged by this particular SBOM. I will run through, let's jump into a short demo to generate an SBOM so that we can further go through, or else I might put you all to sleep. Okay. So let me just. Is it visible to people on the back row? Okay, I've got a simple container doing nothing much, an obligatory hello world container, and if I want to know and understand what's in the container currently, let's forget the fact that we know about SBOMs right now. If I need to know and understand what's in the container, the only way that we can generally do it is by jumping into the container. I would generally run a bash on it, and I would sort of say, okay, what's within the container? There's nothing much over there, but I know that it's a container which is running a .NET application. So I could sort of say, okay, what's the version? I could just give me a minute. Dismiss this. If I need to understand more, for example, if I need to understand what's the version of the OS that it's running, I need to know where to look for it within the container. A lot of people find it hard to even figure out within the container as to which OS are we running within this container, right? So for example, this I know for sure is running Debian. Yeah, it's running Debian 11, Bullseye. So this is how we figure out what's within the container. If you want to know and understand what else is within the container, again, as I said, this is what you get from the generic container-based package that I use to create this container. And I can tell you, I know this is a hello world application. It doesn't need any of these things, for sure. Right? Okay, so yeah, you can install. So Sift is a tool to generate SBOMs. It's an open source tool. You can install it from GitHub. Let's see how I can generate an SBOM. So let me just generate an SBOM. Sorry, I need to exit the container first. So yeah. So this basically produced, so Sift basically ran through, introspected the container, it cataloged all the packages within it, ran a bunch of catalog analyzers to sort of say, okay, what does a container contain? And it generated an output to say it has 101 packages. As I said, basically it has the ASP.NET Core runtime and the .NET Core runtime, and the rest are all the base Debian packages which came in along with the base container, right? So this is what is the SBOM. Now if you need more details about the SBOM, we can even generate it as output it in JSON format. This produces a lot of information, but yeah, this helps you sort of know and understand better what the container contains. Okay, so right now what we've done is we've used Sift to generate an SBOM. We've also formatted it in JSON so we can extract more metadata out of it. Now the next part is attesting or signing on the SBOM to make sure that we can cryptographically sign the SBOM, and that's where I would use Cosign. Again, Cosign is an open source platform. It helps you to generate signing artifacts to sign SBOMs primarily. What I'm doing over here is generating a key pair. It primarily generates cryptographic keys, a public key and a private key, so that I can sign the SBOM. I've already generated the key pair, and what I'm doing over here is I will use the private key to sign the SBOM. what Cosign is actually doing right now is it's extracting the SBOM out of it, and it's basically signing the SBOM. I'm sorry, it's at the bottom. I'm sure people behind can't see it. I'll try to pull it out. Okay, now that it's been signed, it's also pushed a signature to Docker Hub. I'll just get into Docker Hub. Nope. Another issue with an image is that one of the factors that was discussed is where would the signature be stored. The signature unfortunately cannot be stored in an image because an image doesn't allow a signature to be stored. So the signature is stored in your container image repository. Just give it a minute. Okay. So what we did right now is generate the SBOM, and then we generated the SBOM using SIFT, and then we signed it using Cosign, and Cosign not only signed it but also uploaded the SHA digest to Docker Hub. And whenever somebody wants to now download this image, they can authenticate and make sure that the image that they are downloading from Docker Hub is a SHA-signed image that they've already verified from an SBOM perspective, and they know what exactly they're downloading and what's within this particular container. So a container is no longer a black box which you don't know what you're downloading. Rather, you exactly know what does your container have, whether you're comfortable with it, and whether you're sure of what you need within that particular container. So this is one whole process. I've simplified it a lot. I've reduced it a lot to just the basics alone. What else? Cosign, there is also an experimental way wherein there are a bunch of other open source tools also working in the background. So there is another open source tool called Fulcio, and there is Recor. So Fulcio is similar to Let's Encrypt, wherein Fulcio gives you root CA certificates so that you can sign your software packages, and there is a verified history of or verified line of trust across your software packages. And similarly, Recor is a storage system wherein you can store your signed SBOMs publicly, so that you can go in and verify if you download a particular container image as to what does it contain, whether there was any modification, what's happened down the pipeline as we run through. These SBOMs are also further used for scanning. For example, Gripe is an open source scanning tool. Again, it scans containers for vulnerabilities, and the way Gripe scans containers is it initially generates an SBOM, and then it doesn't rather scan through the whole container by images, by the image layers, but rather it generates an SBOM and then scans the SBOM against this database of vulnerabilities and ensures that there is no match. So I'll just sort of run through this. Yep, it ran a vulnerability scan against this image, and it identified 85 vulnerabilities. And I just downloaded this image and created a Hello World application, nothing else, right? So that's a level of exposure that you have if you just download an image and basically do nothing with it. And if you deploy this to production, you basically increase your surface area of attack, right? So, is there anything else? Yeah, so
Can I just ask quickly?
Yeah.
Did Gripe and SIFT do second order, third order dependency?
Yeah, they do transitive dependencies too. They do check through the whole transitive dependency chain.
Okay.
So as I said, this is more about Fulcio and Recor. How many people here are aware of OPA and Gatekeeper? Okay, OPA is Open Policy Agent. Gatekeeper is used to enforce policies in your Kubernetes cluster. So right now we do have an option to provide provenance as a policy. I'm sorry about the, yeah, I can reduce it. So right now there is a Cosign Gatekeeper provider. Basically what this does is whenever you try to pull an image, it goes and verifies whether it's a signed image and whether you trust the signature authority of that particular image, and only if you trust it would it then pull it into your Kubernetes cluster, or it would reject that particular pull. So you need not have to go out of your way to do anything additionally to ensure that you're pulling in only secure images, but rather you have a gatekeeper policy set up which already ensures that this happens automatically. And I just went through some additional details of how it goes to get external data. It goes into your Docker image registry, figures out this signed SHA and sort of verifies it and ensures that you're only pulling in a signed image. So yeah, that was my talk about securing your supply chain. Basically knowing and understanding that you're deploying safe, secure containers in your system, you're generating safe, secure packages, you're taking care of your customers, and you're taking care of everybody downstream from you and the overall community. Thanks everyone.